In this video, we are going to build serverless API using API Gateway connecting to backend Lambda and DynamoDB table as a data store. First, we'll build this completely manually, understanding the concept, how to build API, and then automate using CloudFormation template. And I will provide all the scripts I'm using, and CloudFormation template is in GitHub repository, so you can try on your own and learn from doing. So without further delay, let's get started with value-packed tutorial. Hello everyone, I'm Girish Mukim, AWS Solutions Architect, AWS Ambassador and Community Builder. If this is your first time on this channel, here we simplify AWS concepts with hands-on learning. This helps you level up. If this is you, consider subscribing. Let's first look at architecture, what we are going to build. So we are going to build Hello World API using API Gateway, then backend will be backend Lambda processing, then data store is DynamoDB. So in API Gateway, we'll build a resource which is /hello and couple of methods which is get and post, and validation will happen through Postman. So I'll show you how to do it. First we'll do this complete stack manually, and then we'll see how we can automate using CloudFormation template. This is really popular serverless stack which is used by big enterprises as well. Most of the time, if it is backend execution is required for less than 15 minutes, which is elapsed time allowed in Lambda, then they go with Lambda, or we can go with ECS Fargate, which is for your containerized workload. You can decide how much time you need to run ECS tasks. With this, let me go ahead and start actually building this architecture or solution in AWS Management Console. Okay. First, we'll create Lambda, and whatever I'm going to show you, we'll automate this full stuff, and I'm going to give you GitHub Repo where you can get all the scripts which I'll be using. First, let's create function. So I'll just give hello world API v2 for I'll use Python. So this permission, this is important part. So there is an execution role which will be created as part of this, and I'll show you how to add more permissions to that. But for now, I'll let AWS create execution role in backend. So execution role is very important when it comes to Lambda function. Create function. Right. Before I go and change code for this function, let me create DynamoDB table as well. So I'll create table hello world v2. I'm giving v2 because for actual automation we'll use CloudFormation, so that will use normal hello world table name for the table. So I'll just take one partition key which is id, and that's it. Will not change anything here. I'll just create table. Just need to note down the table name because we are going to use that in our permission. I'll show you when we come there. So let it create, and meantime I'll go and change the code for this particular Lambda. This is the default code what it comes off with. And as I said, you will get this in GitHub Repo as well. Delete this code and use the code which I'll provide you in GitHub Repo. Let me deploy it first. Function is deployed. So I want to show you few things here, right? Like if you go into code is already updated. And if you notice lambda underscore function.py is a default file name for your Python code. Ensure that your handler is correct. If you go down, I'll just show you from the beginning. Yeah, you are in code. Just go down and make sure lambda underscore function is correct. So here for our function, we just need to use lambda underscore function dot handler. This is the handler name we are using inside our function, so you just need to make this change. Perfect. So once that is done, I'll go to configuration. I will add environment variable, and this will be created as part of CloudFormation template for you. When you are doing or learning manually, right, you should do it here. So value, it is actual your table name. So this is how we are giving name of the table inside our Lambda. Let me search table. This is the table name, so I'll just go here. Give the table name here. Okay, save. One other thing we want to make sure that permissions provided to the execution role. So if you see execution role by default only get access to your CloudWatch logs, right? It doesn't get access to any other resource. But now as we want to change it to allow access to our DynamoDB table, you will just go to this role. I'm just opening the role. Meantime, I'll just find out the ARN for my DynamoDB table. I'll just copy ARN here, right? You can copy it. But before that, let me open the policy. Here I want to change the name of ARN for my resource. Take the ARN and copy paste this. That's it. This is the only change you want to do. And if you can see, I'm just only giving put item and get item permissions. I'll keep this as is. Now let me go back. We want to add this permission. Add permission. I'll create a new policy. Add permission. Create inline policy. Just take JSON because I'm going to give you complete policy. That's it. So once that is done, you just go to next. You need to give some names. I'll say Lambda to DynamoDB policy. So let's say v2. So we'll create policy. That's it. So this policy is attached. So Lambda got permissions to operate on DynamoDB table. Let's verify that. Verification can be done from Lambda side before you hook up a API gateway in front of Lambda. I'll give you one event, like event you can pass to Lambda. Close this and you can test it. Create a test event, then we'll give this event, and this event I'll give you JSON file. I'll give it in GitHub Repo. So with this, let me save it first so we can reuse if we require and test. Okay, perfect. If you can see, it says data saved. The actual saving of the data is working. So our Lambda is able to go to DynamoDB table and write to same table. So if I go here, explore table items, we can see that, okay, there is some value which came as part of this particular test what we did. Okay, so Lambda is looking good. So let's go ahead and create an API. So we'll go with REST API. Start building it. So I will give hello world API v2. Description is optional. So just create API. So once API is created, next thing is you need to create a resource. And I'll say resource as hello. Create resource. So you can see /hello. So your endpoint /hello will be your path so far. I want to have couple of methods. We looked at architecture and we say we want to create two methods, get and post. So let's create two methods. First, I'll create post. I'll put Lambda function. I'll say Lambda proxy integration, what I want to do. There are multiple options when we are creating methods, but we'll stick to a simple use case where we are just saying backend processing is done through Lambda. Lambda will be hello world v2. So everything else will remain the same. We'll just create third. There are other attributes and it's very powerful, but for now we are keeping it very simple. Just one post method and giving Lambda function as a backend processing. I'll create one more method. So this is one which is post. Let me create one more method which is type is get. So essentially what we are doing is we are putting some 1 to 3, right? I showed you that. So now using that ID, we want to fetch record, and that fetching will happen through get. Lambda, I'll just still use hello world v2. No changes whatsoever. So once you create resource and method, go ahead and deploy this API. So while deploying, it asks which stage you want to add. You can create multiple stages, dev, prod, test, whatever you want, but I'll just create one dev. So deploy, that's it. Description is now like optional, so I'll just leave it there. So if you can see that the stage is created. So now if I go into this stage, I can see exactly same resource and methods what we have created. So let's check, for example, for post method. This is a URL /dev/hello. So now we are looking good, right? We have created API gateway. We had created Lambda. We had created a DynamoDB table. We changed or added Lambda execution policy. So it get access to DynamoDB table. So, okay, with this, let's go ahead and test it out what we have done so far. Right, I'll go to Postman. For hello world, I have created this API in Postman for testing. I'll give you like configuration as well. So you can pretty much import this configuration in Postman and you can use it. You don't need to build it from scratch. One variable which we are using there is base URL. So let me change base URL to actual current value. So let me go back to API gateway, pull this. Now copy this, go into your base URL variable, and this will be in hello world API. If you click here, there is no variable because our variable we are setting it as API level, not as at method level. So just go to your API, change base URL current value to existing value. You remove hello because we are giving that hello as a path in the when you are invoking. So this is good. So let me see whether we need to save. Yeah, we need to save it here, save. And now we'll post some record. So here 123 is already added. So let me make it 124. That's it. And send. Base URL, it will be taken from the variable, and then hello we are giving, which is our path. Is send. Okay, great. So we can see 200. Okay. So our post method is successful and we can validate as well. You can even go into logs and validate that it is working. And if you go to monitor and the logs, right, you can see it in CloudWatch log itself. Or otherwise, easy way for this particular use case will be go here and run, so that you can see, okay, 2 records should be there now. If you see 124 is added. So now if I go back to the Postman, let's validate our other method, get. So get is hello ID. We are saying 123. So you can see 123 I have given as a query parameter. It should work as well. Yeah, some error. Let's see what is that error. So let's troubleshoot this. So when we are using post method is working fine. We are able to update DynamoDB table in backend through Lambda. But in case of get, it is not working. And it is giving us some weird error. and we need to investigate what's happening. So let me first go into API Gateway and look at proxy integration for post method. If you see, it is Lambda proxy integration is true. In case of get, it is false. And we will need to understand what is Lambda proxy integration. So let me explain you what is Lambda proxy integration, and then we'll change it to true and see whether that helps. So with this, let me just explain you what is proxy integration. First, how it will look like when you are not using proxy. I'm just taking analogy here, waiter and chef in the kitchen, right? Waiter, you can assume it as a API gateway, and chef is your actual Lambda which is processing it. So assume that you are not using proxy integration. So what happens is, user comes to a restaurant, he gives the order, which is nothing but web request. He gives the order, waiters take the order, it translates that request or order in a specific format. So waiter takes the request, is put in specific format which chef understand in the backend, saying that what is this, what is the spicy level, what is the size of the dish customer is looking for, and what are the excludes, customer doesn't want something for that dish. So all that customization or whatever understanding waiter has, it will convert that into the specific format which chef understands, and chef take that format, he work on create a dish, creates the dish, it sends back to waiter. So waiter won't transfer the dish as is to the customer, he adds some customization to that. So he will put the message saying the enjoy in his box, whatever his or dish is getting back to the customer. So it gives back to the customer, and that's how the request is processed. We are able to serve you a web user. Okay, this is how it will happen when it is not using proxy integration. It does required mapping template. What does that mean is, if you see the order given by the customer was in certain format, orally customer gave the order, but waiter has to transform that order or put it in the specific format which chef understood. This mapping has to be done when you are not using proxy integration. But how this will look like when it is a proxy integration, Lambda proxy integration. So you get the order or you get the web request, and waiter, without making any changes whatsoever, it just passes that order to the chef, right? It might be like you are giving some form to the customer, he is putting like whatever details he wants to put, that order is directly given is to chef, and chef works on it, he creates the dish, gives it to the waiter, and it passes back to the customer. So here waiter does not make any changes to request which coming from the customer, as well as the response which is coming from the chef or your Lambda in the backend. So hope this makes it clear. And what is happening in our get method is, we are taking the request, we should be using like the based on the code what we have written in the backend, it is expected to just pass the request from web request from Postman and pass it directly to our Lambda in the backend. That is expected because we haven't put mapping template as well. Like whatever request is coming, we haven't put any mapping template and then send it back to the backend. We directly was supposed to pass as is. But as our proxy integration is false, this might not be working. So let's first see whether that is the case. So I'll just go to the integration request, edit. I'll keep everything as it, just I'll change it to Lambda proxy integration. Come here, save. So this is true now. So I'll deploy this API in the same stage what we have created in the past. Deploy it. Our API is deployed. So let me go back to API. Then I'll keep it as is 123 and send the request. Okay, it's still not working. But let's give it 2 moments and check it again, because I have seen this earlier. When we are making any changes on API and we deploy it, it takes a bit of a time for that to reflect and request to be successful. Great. It took a little bit of time, but now the request is flowing. So let me do it with 124. That is another ID we use, 124. Perfect. So that was the reason our Lambda integration was not proper. We didn't choose a proxy integration. Hope this makes clear to you what is the proxy integration and what when we are not using it. Now let's look at how we can automate what we learn. So first step was to learn the concept, how to do it manually in console. And the second step is doing it through CloudFormation template. I'm going to create stack, choose an existing template. I'll upload it from my local machine. Then I'll go next, and this is nothing different than what we already built. I'll just go next. I'll not change anything. I'll just acknowledge that it's going to create IAM resource. Like you have seen that manually, we had to create IAM role and policy to attach to it. So that is automated here, but I want to just accept that we know that IAM resource will be created, and that's it. So with this, just submit the stack. And while this is creating resources,
I can explain the stack to you. Essentially, it's create DynamoDB table. It create the function role which will attach to our Lambda. Then it create the policy what we have seen before. So it create the policy. It create function. Then we'll create a gateway. Then we'll create resource, hello resource, what we have seen. Then methods, two methods will create, and that is how the deployment will work. And there is a base URL which we are giving as a variable that is also part of the stack. So with this, let's go back to our CloudFormation template and see where are we. Okay, so resources, if you check it here, these are the resources what the stack has created. You can just review it and then you understand yourself like what all resources it's creating. Okay, perfect. It's creating everything what we need. But one thing we should do now is go back to API Gateway. So I'll go to the APIs. Hello world. Yeah, V2 is what we created manually. So I'll just go to this particular resource, like a resource or API. Then stages. I will go to say post, copy this URL. And you know that we have base URL in Postman where we need to key in this. So I'll go to hello world. You don't need to change anything here, right? Basically, you just need to change this base URL. Base URL, we don't want hello. That's it. Just remember to save. Otherwise it won't work. So you saved it. Now go to post. I will change this to 125. 4 shouldn't be there because this is like a new API which sending, or DynamoDB table is also different, so it should not be there. So you can really send this 124 itself. Perfect, it worked. Now I'll send 127 just so that we are sure that it's working. Okay, it sends as well. In a get method, I'll send 124 because we know like we sent it before, and then I'll check for 127 as well. Okay, perfect. So this is working, and that is the beauty of automation. Here we didn't make any mistake because it's automated. CloudFormation stack was already prepared, so it knows what all is needed for this resource to be created. The Lambda proxy integration, what we talked about, it's already know like that is needed for get and post as well. So that's the beauty of automation. But before even we go to the automation step, we are doing it manually, so we understand that. So now we understand what is Lambda proxy integration, right? Then it makes sense and it's fun to try it out through automation and see that it's working. And in real world, definitely like we'll use automation more often, but to understand, learn, manual step is needed. So I want to show you both the flavors of it.
You learned something new today. If so, please like this video, share, leave your comment so that I know this content is helping you. Don't forget to subscribe, and that's now. See you again with yet another exciting tutorial about AWS. Keep learning, keep sharing what you learn, and thanks for watching.